In this video, we will talk about our linear application fill-in-the-blank notes. After you see this will show you all the different ways to solve different types of problems of linear, how to deal with them. So let's jump into it. When a word problem involves a constant rate, we have a linear relationship. There are multiple types of linear applications. These are with context. You might be given a slope and a y-intercept problem. That means that literally in the problem they tell you the slope and they tell you the y-intercept. Or you might be given the slope and maybe a point. That point's not the y-intercept. You might be given 2 points. You might be given a table. You might be given a graph. Or you might be given a standard form equation. And here are the steps to do linear applications, or any linear problem really. First, verify the problem is linear. It'll either tell you it's linear, it might tell you that there is a constant rate, or you need to verify the points actually have a constant slope. Once you know it's linear, try to identify the mathematical concepts, such as points. Maybe one of those points is actually the y-intercept, the slope, and any variables. That's what you're trying to find. Once you know your points, or y-intercept, or slope, and you're trying to find, which is your variables, then you want to try to find the slope. You may need to use the slope formula. Remember, the slope formula, our letter we use is m, which is equal to y2 minus y1, where x2 minus x1, where x1, y1, and x2, y2 are points on the line. Once you know your slope, you can use the slope in one of the points to either write a point-slope equation, which you can later solve into slope-intercept form, or you can use your slope and your point to find the y-intercept. Once you have your slope and your y-intercept, you can then write your slope-intercept equation. If it happened to be in standard form, you can actually solve it to y equals equation, puts it into the slope-intercept form. And then once you have your equation, you're going to have one of two scenarios. Either you're going to be given the x, which means then you need to find your y, or you're going to be given the y, which means then you need to find the x. Now sometimes they're not the x and the y, they might be a and b, or whatever letters you're using, but x is your input, and y equals output. So these are the steps to solve any linear problem. Below are multiple versions of the exact same problem. Scenario 1 through to scenario 5. I through V is Roman numerals. Depending on the information you're given, it tells you where you start then at the different steps. All of them are answering the same original problem. Example 1, 2 points. And if you have this scenario of 2 points, you're going to do all of the parts A through H. Let's clarify that. For example, if you have scenario 1, which is 2 points, then you would have to find the answers for A through H. You need to mathematically find the slope for part A and the y-intercept for part B, and you'll write the equation for part C, and then solve the other parts on D through H. Now, let's say instead you actually had scenario 2, where that's given the slope and a point. On the first scenario, we had 2 points, so we had to find the slope, y-intercept, and the equation. Now they tell you the slope and a point. So now you only have to do parts B through H, because the slope is already given in the problem. They literally tell you what the slope is. So now you just have to find the y-intercept in order to create the equation. If you have scenario 3, where they tell you the slope and the y-intercept, and now you're just starting at part C, not doing parts A and B. So again, they already told you the slope, they already told you the y-intercept, it's literally in the problem. So you don't have to mathematically find them. All we have to do is start at part C, where we're going to write the equation. So let's look at what that means. On this problem, we're going to be given 2 points. So in this scenario, you do parts A, B, C, D, E, F, G, and H. So let's then we're given this scenario, a problem. A scientist is studying the depth of a flowing river. Scientists found at the end of March the depth was 16¼ feet deep. At the end of September, the depth was 11¾ feet deep. Assuming the river is losing water at a constant rate per month, how much water was the river losing per month? And what mathematical idea is that? Is that slope or y-intercept? Because it says that it's a constant rate, we're assuming constant rate, that means it would be linear. Since it's linear, we know that we could write an equation. So, first question, how much water is the river losing per month? Which idea is that, slope or y-intercept? That idea is slope. The word per is typically a word that's associated with slope. How much water are we losing per month? So it's a rate. Rates are slope. Since we're trying to find slope and we have 2 points, we can use the slope formula. M equals y2 minus y1 over x2 minus x1. March is the 3rd month. September is the 9th month. So we would have March, comma 16¼ That was what it told us up here. And September was 11¾ feet deep. I can turn March into the 3rd month. 16¼ is 16.25. And September is the 9th month. And 11¾ is 11.75. It's a lot easier to use the decimals than it is the fractions, so we're going to use the decimals. Plug in these points then into our slope formula, y2 minus y1 over x2 minus x1. Show me what you get. We get 11.75 minus 16.25 over 9 minus 3. On the top, we get negative 4.5 over 6. Reducing that to a fraction gives us a negative 3/4. Now, fractions don't leave decimals in fractions. It has to be integers or whole numbers. So a negative 3/4. This means that we lose 3/4 of a foot of water per month, which makes sense. It's a negative. We see that I start at 16 1/4 in March. Therefore, in September, I have a lot less, so my slope should be negative. Instead of thinking of 3/4 of a foot per month, you could also think of it as you're losing 3 feet every 4 months. Remember, it's a change in y. Y here is feet over the change in x. X is months. So the fraction 3/4 really means losing 3 feet every 4 months. So in scenario 1, where I was given 2 points, I had to find the slope using the 2 given points they gave me. Once I have the slope, what I'm going to do now is use the slope and one of the points they gave me to find my next part. So after you finish part A, you would move on to part B, then part C, etc. if you had scenario 1. However, if you have scenario 2, then you would just start at part B. Let's take a look at that. For scenario 2, I'm going to be given a slope and a point. So now, if this was the problem I was given, instead of the problem of scenario 1, where I was given 2 points, you wouldn't have to find the slope like we did. As you'll see, we're actually given that information in the problem itself. So if you're given a slope and a point problem, you don't have to do the slope, you just have to start at part B, which we'll talk about in a moment. So scenario 2, a scientist is studying the depth of a flowing river. Scientists found at the end of March the depth was 16¼ feet deep. The scientists then found the river was losing water at a constant rate of 3/4 foot per month. Assume the river is losing water at a constant rate per month. What was the height of the river initially from the beginning of the year in January? What mathematical idea is this? slope or y-intercept? Well, that idea is going to be the y-intercept. We know that because it's that word initial or beginning. Those starting amounts are our y-intercept idea. One other thing to note, it says that we're losing water at a constant rate of 3/4 foot per month. What does losing imply about our slope? It means that our slope is going to be negative. So my slope here is a negative 3/4. Notice that this is really part A. But I didn't have to do any math. It told me that number right in the problem. So I don't have to work that hard. I can just use the slope and one of the points to either write a point-slope equation or to use the slope and one of the points to write a slope-intercept equation using the slope-intercept form. Both methods, using the point-slope form and the slope-intercept form, can ultimately get you your y-intercept. Let's look at using the slope-intercept form to try to find our answer. Remember, y equals mx plus b is our slope-intercept. Here, I'm going to use d for my depth and how deep it is. M is going to be my slope. T is going to be my time. And b is going to be my y-intercept. We know m is negative 3/4. We also know that there's a point at 3, 16 quarter, or 16.25. We know that from up above, right? That was given in our problem. March is the third month. 16.25 is 16.25. We can use that information, plug it into the y, m, x, and b part, and try to solve for my missing variable. So what will go in these blanks? Take a moment, try that. Otherwise, that's going to look like this. 16.25 is my y. We're going to know that my negative 3/4 is my m. 3 is the x. And then plus b. Because we don't know what the y-intercept is, right? That's what we're trying to find. What was the height of the river initially? We don't know. Whatever you're trying to find is your letter. Now, I'm just doing an algebra to find b. Negative 3/4 times 3 is a negative 9/4. So the plus b equals a 16.25. It might be easier to write negative 9/4 as a negative 2.25. Decimals are usually easier to deal with. But you could leave it as a fraction as well. But we want them to be the same. So if we have a decimal, easier to keep them as decimals. Or I could turn them both into fractions. In any case, I'm going to add 2.25 to both sides. 16.25 plus 2.25 means that b is, here we get 18.5. That means that my starting amount was 18.5 feet for my depth in the beginning of January. So in order to write a slope-intercept equation, you have to know the slope and you have to know the y-intercept. Sometimes you have to find both. Like if you're given a scenario where you're given 2 points, like you were in scenario 1. There I had to do the slope formula to find my slope. And then I would have went to part B where I had to find the y-intercept using the method we use on the right here, plugging in my y, my m, and my x, and solving for b. Or maybe you had scenario 2, where they actually tell you the slope right in the problem. Then I only have to do part B. Notice, doesn't matter which scenario it is, it's still the same process of finding a slope, either using the 2 points, or given, and finding the y-intercept, which sometimes you have to solve for. Once you know those two things, you can write your equation. That's what we'll look at in scenario 3. On scenario 3, in this problem, you're given the slope and the y-intercept. For example, a scientist is studying the depth of a flowing river. Scientists then found the river was losing water at a constant rate of 3/4 foot per month. Their initial test of the water's depth at the beginning of January was 18.5 feet. Assume the river is losing water at a constant rate per month. Now we can just write the equation. Notice that our slope and our y-intercept are given in this problem. Or if you had scenario 1 or scenario 2, you would have had to solve. But either way, you eventually get to the same scenario. These are three different scenarios about a river losing water based on different information, but they're all really the same problem. It just depends on what information I give you. In any case, write an equation where the water depth in feet, d, is a function of the time in months, t. This d of t is called function notation. It means that the depth depends on the time. I'll show you what that means here in a moment. First, let's write what our slope and y-intercept will be. What will go in this blank, in the blue, in front of the t, and what will go in this green blank after the t. For the blue blank, we are losing at a constant rate of 3/4 foot per month. That's our slope, so negative 3/4. T plus our y-intercept, starting amount of 18.5. We'll do 18.5. This was the same slope, same y-intercept we found on part A and part B. Notice if you're given this scenario, scenario C, I don't have to do any math. It literally tells me the slope and the y-intercept in the problem. I just have to write the equation. Sometimes you have to find the slope, sometimes you have to find the y-intercept. Not in this case. Once I have my equation then, I can use that equation to answer other questions, like part D and part E. Let's look at part D. What is the depth of the river at the end of July? How would I find that? Well, we know July is the 7th month, so I would put 7 in place of T. See how T is 7? That means wherever you see T, you should put 7. This means in this first blank, we're going to write D of 7. This does not mean the depth times 7. This means that I'm going to get a depth in terms of 7 for my months. Remember, what that 7 did is put wherever a T is, we're putting 7. This becomes negative 3/4 times 7. All you're going to do then is negative 3/4 times 7 plus 18.5. Type it in your calculator exactly like it says. Just the right side. We don't worry about the left side. Negative 3 divided by 4 times 7 plus 18.5 is 13.25 feet, or 13 1/4 feet. That would be my depth of the river at the end of July. This is that given X idea. What is Y idea? Now let's look at part E. At the end of what month will the river be 14 3/4 feet deep? In this context then, we know that the depth is 14 3/4 of a foot, or 14.75. We put that in place of the D of T. So 14.75 equals negative 3/4 T plus 18.5. Take a moment and try to solve that. Otherwise, that's going to look like this. We start by subtracting the 18.5 from both sides. 14.75 minus 18.5 is a negative 3.75. That's equal to the negative 3/4 T. To get rid of fractions, then we multiply by the reciprocal. That's flipped fraction. So it was a negative 3/4. We multiply both sides by negative 4/3. Negative 4 divided by 3 times negative 3.75 gives us exactly 5 months. 5 months translated back into the name of that month is end of May then. So that means that the depth of 14 3/4 feet would happen at the end of May. These are the kind of questions then we can answer once I have my equation. I can find the depth at any month. I can also find a month at any depth. Again, once you have your equation, it's one of two scenarios. Either I tell you the x part, the input part, plug it in, find the answer, or I tell you the y part, output, and then you solve the equation to algebra to get your x part, your input part, in this case t. We can then extend those ideas to find other types of questions. For example, let's assume the trend continued. How high is the river at the end of 1.5 years? Well, our problem here is we're talking about months for time. Time is months, but here we have years. So what we need to do first is figure out how many months would that be? What is 1.5 years as months? That would be 18 months. We know that because there's 12 months in a year. Half of a year is 6 months. So 12 plus 6 is 18 months. We have to use 18 months. Months, is that the T or is that going to be the D? Well, time is months, so we're plugging 18 in for the T. Remember, what that means is wherever you see T, you're going to put 18. Negative 3/4 times 18 plus 18.5 gives me a depth then of 5 feet. Last question that might happen. When will the river dry up? That is a very common question, something I want to know. So when will the river dry up? Well, what would be the depth then for a dried up river? The depth of water would be 0 feet. What this means then is we're putting 0 in place of the D. So 0 equals negative 3/4 T plus 18.5. You'll notice that that's exactly the same as what we did with part E, except we had 14.75 as my starting point for my depth. Now we're starting at 0, but it's still the same exact process. We're still going to subtract 18.5 from both sides. We're still going to multiply by the reciprocal, negative 4/3 on both sides. The time when it dries up then is 24.6 repeating months, or 24 2/3 of a month. So that's how many months it will take to dry up. Notice that the question just says when. It doesn't specify what type of answer it wants. It doesn't specify that it has to be the name of the month or that. So since it just says when, I could just answer this as 24.6 repeating months, or 24 2/3 of a month. Letter H, though, wants us to find the exact date that the river dried up. So what we have to do is use that 24.6 repeating months, and we're going to take the partial parts and convert them into our next unit lower. First things first, where would the 24 months be? Well, since we start in January, 24 months is exactly 2 years. So what happens is we are already then back to January. We then take the 0.6 repeating months, multiply it by 31 days in January, that's 20.6 repeating days. Now we take that 0.6 repeating, or 2/3, multiply it by the 24 hours in a day. You'll saw that I did as a decimal or a fraction, either way, same thing. Use the 0.6 repeating day. There's 24 hours in a day, so we multiply the 0.6 repeating times 24, or 2/3 times 24. That gives me 16 hours. 16 hours then from midnight, 12 a.m., puts us at 4 p.m. So I should be drying up on January 20th at about 4 p.m. Notice how accurate then we can predict things. This is, of course, assuming that everything stays the way it is. There's no other factors. This is actually an estimate of what should happen. Mathematically, though, this is the exact number that I would expect. Remember, what I'm trying to do here is, given some scenario, I'm trying to write an equation. I'm trying to use that equation then to predict future outcomes. This is really only an estimate of what should happen if everything goes correctly. Doesn't always work exactly like we want it to, or if there's other factors involved. But this is what we do. Take a real life situation, turn it into an equation, and try to use that to predict future outcomes. This is our model that represents this situation. So we've seen story problems where maybe I'm given 2 points, like scenario 1, a slope and a point, like scenario 2. Maybe I'm given a slope and a y-intercept, like scenario 3. Here's another scenario. Let's say I'm given a table. When you're given a table, there's a couple things you have to do. First, we have to verify the table is actually linear. If it's not linear, we can't make it in linear equation for it. A couple ways that you can know that a table is linear. First, the context might just say it is indeed linear. The context might say that there's some kind of constant rate. If it doesn't say those first two scenarios, then you need to verify the slopes are indeed a constant rate, meaning you need to do the slope formula on all sets of points next to each other. Those are called consecutive points, points that are next to each other. If all of them are indeed constant, then we can make a linear model. And we follow the same steps we did from 2 points and do the slope formula to find our slope. If it tells you it's linear and or a constant rate, then I don't have to do the slope on one of them. Otherwise, I have to do the slope on all of them. And then once we have the slope, we can find the y-intercept using the slope in one of the points and make our equation. So let's say we're given scenario 4. A scientist is studying the depth of a flowing river. The scientist's funding only allowed them to visit the river a few times throughout the year. They found the following depths at the end of the different months. March it was 16.25 feet deep, and May it was 14.75 feet deep. August 12.5 feet deep, and in November it was 10.25 feet deep. What we need to do is find then the slope between them. At no point does it say that we have a linear model. Like we did before on scenario 1, we're going to take the 16.25 and convert it into 16.25. Same thing with the 14.75, turn that into 14.75 for the May and March. Also like before, March is the 3rd month, May is the 5th month. We can do the slope formula, taking our y2, 14.75, minus our y1, 16.25, over our 5th month minus our 3rd month. On the top, we get negative 1.5 over 2. We can turn it into a fraction, either on the TI-84 calculator by simply typing the negative 1.5 over 2, then just hitting the math, enter, so give you a reduced fraction. You can also do it on decimals, just typing in the negative 1 divided by 2, and then hitting a little fraction looking thing to the left of your numbers that you typed, and you'll see a reduced fraction. No matter what, we get negative 3 over 4 as my reduced fraction. We do the same thing between May and August. August is the 8th month, and 12.5 is 12.5. Again, taking the 12.5 minus the 14.75 over the 8 minus 5. This time we get negative 2.25 over 3. Again, reduce that fraction. Turns out to be a negative 3 over 4. Couple of reminders. Remember, fractions cannot have decimals in them, so we have to convert it into, should just be integers on top and bottom. Secondly, this is also why we always reduce our fractions. Notice that the negative 1.5 over 2 and negative 2.25 over 3 look nothing alike. However, when you reduce them to the simplest form, they actually are the same fraction. So it's important that we're all reducing to the same simplified fraction. That way we can actually compare them. Between August and November, then, we would have 8, 12.5, which is 12.5. And then November is 11th month, and 10.25 is 10.25. Do the slope formula between these points, and let's see what we get for a simplified slope. Take a moment, otherwise that's going to look like this. First we have 10.25 minus 12.5 over 11 minus 8. That gives me negative 2.25 over 3, just like the previous one, where that means it's going to be the same. As a decimal, we get negative 0.75, or as a fraction, negative 3/4. Notice the relationship between all three of them is exactly negative 3 over 4. Therefore, we can say it is, since all the slopes reduce to the same constant rate. Now, one of the things that we can do then, since all of them reduce to the same constant rate, is we can write our linear equation. We already know the slope. We can just pick one of the points, do just like we did in part B with our scenario 2, where we're given the slope of the point, find the y-intercept, and use the y-intercept to write our equation. And just one other quick note about real-life models. In real life, it doesn't always work out very nicely. These wouldn't necessarily all be exactly negative 3 over 4. But if they're relatively close, like plot the points, if they look like a straight line, relatively close, I could use a linear model. It's just not going to be as good as maybe something else. That idea is starting to get in what's called the correlation coefficient in the linear model. And it really talks about how good that model represents our data. But that's for a different time. So again, with tables, they have to tell you it's linear, tell you it's constant rate, or you have to find the slopes between all of them. If they are the same, or relatively close in a real world problem, we can make a linear equation then using the slope and one of the points to find our equation. Use that equation to predict future outcomes. Another scenario you might have is a graph. If you're given a graph, then find at least 2 points on the graph that goes through the coordinate grid, or use any given labeled coordinates. Try to look at the point where the graph crosses the y-axis. That's right here. Remember that coordinate is called the y-intercept. The y-value of the y-intercept point is b in the slope-intercept equation, y equals mx plus b. Hopefully, one of those points is our y-intercept, but it's not always obvious either. That's from below. Here, I can't tell exactly where that crosses. I can tell it's somewhere between 18 and 19 on the y-axis, but I don't know for sure what it is. Once you have 2 points, you should start at the left point and go to the right point by first going up or down. If you go up, it's positive, and if you go down, the slope is negative. Then we always go to the right on the bottom. That's what's starting on the left and going to the right. So again, we go up or down first. Up is a positive slope, down is a negative slope. Bottom number is always to the right. Again, that's starting on the left point, going to the right point. This will give your slope, where the first step of up or down is the numerator, second step is the denominator of the fraction. Make sure we reduce our fraction or simplify our answers. For example, 8 over 6 reduces to 4 over 3, dividing top by 2 and bottom by 2. Remember, reduce means you can divide top and bottom by the same number other than 1. Or you might have a fraction like 10 over 2. But 10 over 2, remember this line means 10 divided by 2. Well, that's just 5, or 5 over 1. And 5 over 1 can just be written as 5. So if you can just write it as 5, write it as 5. We don't write the over 1. It's implied. We know it's there. So if I say the slope's 5, remember you know that means it's 5 over 1. That would mean we go up 5 and to the right 1. That's how you find your slope. So once I have my slope and a point, I can write my point-slope equation or find the y-intercept if I didn't already see it off the graph. If it's not clearly shown, then you need to solve it algebraically, actually, to verify where it is. So let's take a look at scenario 5. This is a graph. A scientist is studying the depth of a flowing river and came up with a graph below. He let the months be represented by the number where the end of January is month 1, and of February is month 2, and the March is month 3, etc. From this graph, you could certainly find some information on it. For example, we see at 10, there's definitely a height of 11. Maybe also at 2, for example. At 2, I know it's definitely a height of 17. But some of these are really hard to tell. For example, at 5, I don't really know what number that is. I know it's more than 14, less than 15. I could make a guess. Maybe it's like 14.9. But again, that's just an estimate. This is why we want to have an equation. The equation would let me know exactly the number that's going to happen at 5. So this is what we're trying to do. Again, off the graph, you first have to find points that cross the coordinate grid. I showed you 2 of them, 2, 17. There's also definitely one at 6, 14, 10, 11. We can pick any 2 points we know for sure. From that previous graph, this is zoomed in a little bit. Again, I'm not sure what the y-intercept is exactly, but I definitely knew that there was a point at 2, 17. And the second point, where there was a y at 14, was 6. Here was our x's, 1, 2, 3, 4, 5, 6, 7, etc. Here was our y's. Notice that the y's and the x's are counting both by 1s. Because they're counting by the same amount, I can literally just count. Start on the left point, go to the right point. We're starting at 217, I'm going to 614. I see up or down first. We see we're going down. Down 1, 2, 3 to the same parallel as our 614. We then went to the right. 1, 2, 3, 4 to get from 2 to the 6. This means I went down 3 to the right 4. That's a negative 3 over 4 as a slope. Once I have the slope, I can pick one of the points. Here I picked 2 for the x, 17 for the y. M is negative 3 over 4. And now you're just doing an algebra problem to find b again, using the slope-intercept form. Negative 3/4 times 2 is a negative 3 over 2. Or that is a decimal is a negative 1.5. Opposite of negative 1.5 is positive 1.5. So I add 1.5 to both sides. And we see that the y-intercept is indeed 18.5. Probably what you might have guessed, but now we know for sure. That could have been 18.53. We don't know until we do the algebra, since it doesn't cross the coordinate grid at a really good spot. So now we have our slope and our y-intercept. I can easily write my slope-intercept equation. Before we get into doing that other stuff, a couple of things about graphs. Be aware of whether the scales in the x and y axis are the same. If they're different, you can't just count them. You need to actually use the amounts for the slope answer. What I mean by that is the y's are counting by 1 and the x's are counting by 1. Because of that, I can just count and have the slope. If these weren't counting by the same, let's say the y's are counting by 2 and the x's are counting by 1, then going down 1 on the y-axis would actually be going down 2 if it was counting by 2's. So that's what we have to be aware of. The other thing I want to be aware of is that the graph can only tell us so much information, right? And most of it's not very accurate. This is why I want to get an equation. Equation lets us go well beyond the graph. Don't have to extend it, don't have to try to do it accurately. Equation will let us find any solution. This is the same scenario as scenario 5, except the different scaled graph. Notice how changing this graph can change the information that you have about it. Still the same scenario, but this time my graph counts by 0.25. Here I can clearly see that the y-intercept is indeed 18.5 when x is 0. We can also see a second point clearly at 2, 17. However, we can't just count down 1, 2, 3, 4, 5, 6 to the right 1. It's not going down 6 in right 1. It's actually going down 1.5 feet. So from 0.5 to 17 is actually only 1.5. Then going over 1 tick mark isn't 1, it's actually 2 months. So be aware of the different scales. When that happens, you can't just count your slope as not -6 over 1. It's actually a -1.5 over 2, and we know that's a -3 over 4 as my slope. So from the graph, we're able to find the y-intercept and our slope. Let's write our equation. Use that equation to find our depth at 10 months, and then use our equation to find the depth of 8 feet. When does that happen? Why don't you take a moment and try to solve that. Pause the video, answer those questions. Should be comfortable doing this by now. This is what you have to be able to do in general. Otherwise, we're going to have this. First, we have d of t equals -3 over 4t plus 18.5. Whenever you have a real-world problem, you should define what your variables are. Here, I'm saying t is time in months. D is the water depth in feet. Remember, this is just a fancy way of writing D. This is called function notation, D of t, not D times t, not true. We're saying that the depth is determined by the time. The time tells me the depth. See, depth is a function of the time. So, using this equation then, if you haven't done so already, try to find the depth at 10 months. Ask yourself, is the 10 going to go in place of the t or the d? Well, that's going to look like this. Well, we put 10 in for t. Remember, wherever we see the t, we're putting 10. So -3/4 times 10 plus 18.5. I literally just typed that exactly like it says in the decimals. We get 11. So my answer is at 10 months, it'd be 11 feet. Now let's answer the last problem. Use the equation to find when the depth is 8 feet. Again, ask yourself, is that going to be in place of t or in place of the d? Now this d of t is really just a fancy way of writing d. As the hint gives you, there's just like part E, just like the previous one was just like part D for the 10 months. This one's like part E for the 8 feet. So, what is that going to look like? We start with 8 equals -3 over 4t plus 18.5. Now we're trying to find what time in months gives me an answer of 8 feet. So unlike the previous problem where I knew the time gave me the answer, now I know the answer, I'm kind of asking what was the question kind of idea. Going backwards, trying to find our x, our input. If you haven't done so already, try to solve this problem. Same way we solved in part E. Otherwise, that's going to look like this. We start by subtracting the 18.5 from both sides. 8 minus 18.5 is a -10.5, which equals a -3/4 t. Now, what would I do to get rid of this -3/4? Multiply both sides by the reciprocal of -3/4, which is -4/3. -4 divided by 3 times -10.5 gives me t equals 14 months. In the decimals calculator, we can take the 8 minus 18.5, we get -10.5. That's where that came from. From there, we multiply by the reciprocal of the negative 3/4 in front of d, so that was negative 4/3. So negative 4/3 times negative 10.5 gives me the 14. Remember, we can also divide by the number in front of the letter. So I could have done negative 10.5 and divided by negative 3/4. Make sure that you have it look like this when you type it in. Still 14. Negative 3/4 is really a decimal, negative 0.75, so I could have done negative 10.5 divided by negative 0.75, still 14. Instead of leaving the negative 10.5 as a decimal, I could have turned it into a fraction. We can hit the fraction button right here next to the negative 10.5. That turns this into a fraction. So negative 12/2 is a fraction of negative 10.5. Could have taken the number negative 21/2 and multiplied by the negative 4/3, still 14. Or even taken the negative 21/2 and divided by the negative 3/4. Again, make sure that big divide part is between the two fractions there. Or it could have done the negative 21/2 and divided by the decimal, negative 0.75. Doesn't matter how you do it. If you do it correctly, we should have came up with 14 units. So this is all the ways that you might run into different problems, other than maybe standard form, which we'll talk about later. Big idea is still the same. We want to write a slope-intercept equation. To find the slope-intercept equation, you need to know the slope and the y-intercept. If they don't tell you the slope or the y-intercept, you may need to find 2 points and find the slope between them using the slope formula. On a graph, you could count. Make sure you count by the actual amount that is changing. The y-intercept, you might have to use a slope and a point to find the y-intercept, or it might tell you the y-intercept. Once you know your slope-intercept equation, you're either going to plug in x and find y, or you're going to plug in y and find x. They might be in different formats. Might be as a graph, might be as a table, might be given 2 points like we did in scenario 1, or a slope and a point like they did in scenario 2, or they might actually tell you the slope and y-intercept like they did in scenario 3. Either way, you should be able to handle most linear problems now.